Today we are going to be talking about section 4.7. 4.7 is titled Glide Reflections. This is going to be our last type of transformation that we talk about in this unit before we get to your quizzes and your tests. This lesson actually is a little bit of a review as well. We're going to kind of go back through all the different types of transformations that we've learned so far, and then we'll finally bring it to the glide reflection and get that last one. So we have this nice chart here at the top that actually kind of explains where all these different transformations we've talked about have come from. You see along the bottom here we have reflection, we have translation, we have rotation, and then finally we're going to have our glide reflection, which is the one we're talking about today. So for a reflection, this is kind of our simplest transformation. This is just the reflection over one line. When we do that reflection, we're going to look at what properties are preserved, and I'm going to write those down below here. So when we had a reflection, we had our A, B, C, D were all preserved. So that was angle measure between this collinearity and distance. Okay, the one that we didn't have there was orientation. So orientation, that one was no good, and we did not have the O there. Okay. When I shift over to a translation, things got a little bit different because now I had that second reflection, because this is the composite of two reflections. I now had A, B, C, and D still, but I also have that orientation. Okay. I'm also adding that extra piece on. Okay. For rotations, I still again had A, B, C, and D, and again I had orientation because that second reflection is undoing the flip in the orientation that happens with the first reflection. Okay. Real quick, just as a quick review, translations, this was with two reflections, but those lines of reflection had to be parallel lines. Okay. For a rotation, these were across intersecting lines. So reflecting across two intersecting lines. And again, we can worry about how much they're moving and what direction based on what those lines tell us. Okay. Then finally, we're going to get here to our composition of three reflections. This is where a glide reflection comes in. So a glide reflection is actually going to use three reflections. We'll come back and fill in that part of the table once we learn what a glide reflection really is. Okay. Up at the very top of this table, we have actually two words. We have isometry, and then we have a transformation. Okay? We've been using that word transformation. That's more of the general term for all these things where we're taking a shape and we're changing it in some way. An isometry is a very specific type of that. Okay? So on the vocabulary part here, we're going to go ahead and fill in the definition of an isometry. Okay? Isometries are transformations that are strictly based on doing reflections. Okay, so an isometry is a single reflection, so just a reflection, or the composite of reflections, either two or three, or even if we do more, it'd still be an isometry. So the composite of reflections. Okay, for our sake, we can think of this just as another word or name for transformation. But if you do go into geometry a little bit further, there are other types of transformations that are not isometries. We're going to get to one as we move into second semester called dilations, or a scale change. That one's not based on reflections, and so that's kind of where that line is crossed. And we'll look at that more kind of as we move forward. Okay. So let's go ahead and shift down here a little bit. Let's talk about a glide reflection. So with a glide reflection, we looked at the top here. We already know now that it's using at least three reflections, but it's a very specific way that we have to use those three. And so for a glide reflection, we have to have the combination of a reflection over a line and then also a translation whose direction is parallel to the line of reflection. That parallel piece is important. If we're not parallel, it seems like it's still a glide reflection, but we actually don't call it that. It doesn't have a special name unless it's parallel. Okay. Now, when we start to do this, if we think about where the three reflections we're actually doing, because right now I only put reflection once. Okay, so that's our initial reflection. This is just one, and I can actually think of it kind of as just one reflection there. But when I do a translation, if I go back up to the top here, that was two reflections over parallel lines. So this is actually another two reflections here, which gives me that total of three reflections. Okay. Now, for our sake, just to keep these a little bit simpler, rarely are we going to consider the translations to reflections. Okay, this is where we're going to use the fact that we kind of figured out yesterday that we can use vectors to help us. Okay, those vectors are going to make this a little bit easier. That way I just have the one vector I'm working with and then my line of reflection. And I'm not trying to confuse doing 3 different reflections all in the right order and everything just to get to the right place. Okay, so we're going to typically use a vector here instead. But you could, if you really wanted to, use 2 reflections there to do that translation. Okay, so let's go ahead and talk about our properties now. So for our properties of glide reflections, okay, if we think about reflections in general and even our composites of reflections, everything preserved here was that ABCD. Okay, we know those are going to be preserved for sure. So that was angle measure, betweenness, collinearity, and finally distance. Now, those are still going to have to be preserved, and those aren't going to go away because those still, even just doing one reflection, preserve all of those. So we want to make sure we're still able to do those. The other side, though, if we look at the reversed, if I do 3 reflections, the one that's kind of questionable is that orientation piece. So when I do 1, the orientation is not preserved. If I do 2, the orientation is preserved. If we think about doing 3, the first one, so my first reflection is going to take and go ahead and flip that shape over. Now my orientation is reversed. The second one is going to flip it back over, then it's back to the same thing. Okay, so it's back to the orientation being preserved. But that third one is going to go back again to the reversed. So our reverse property here, this is orientation again. Okay, if I do 3 reflections, that orientation is going to be reversed. There's no way I can do 3 of them and still end up with that same orientation. Okay, that's going to be important for us because as we start to move forward, I kind of mentioned this yesterday, we're going to start to be looking at our final image and pre-image points and seeing just based on what those look like, what type of transformation we did. Orientation is going to be the key to kind of figuring out, is that doing just a single reflection or a glide reflection, or is it staying the same and we're looking more translation or rotation? Okay. Real quick, let's talk about the notation here as well. Because this is a composite, we're going to use that open circle. Okay. When we do a glide reflection, we will typically do the reflection first. So that's going to go on the far right, because remember we go kind of right to left when we work with these. So I'm going to start on the far right and I'm going to reflect whatever my shape is. I'll call it a triangle for this one, but it could be something else. I'm going to go ahead and reflect that shape first. Then I'm going to do a translation. Okay? And here I'm going to use a capital T because, like I said, most of the time we're going to be using a vector. And so when we get to the example, this will make a little more sense. But that transformation is actually going to be T, which is just the translation using some vector. And that would actually be defined in the problem. It would actually tell us that. Okay? So that's going to be kind of our notation. We'll look at that once we get to kind of our first example. However, we did kind of skip some stuff here at the top. So in this very first picture up top, or in that chart, we had glide reflection. Okay? For all these other ones, we talked about what properties are preserved. So let's go ahead and do that here as well. For a glide reflection, we still have A, B, C, and D. We have angle measures, betweenness, collinearity, and distance. But the orientation now, again, is not preserved. So that orientation is no good. Okay, that one is not going to be preserved. It's not going to be the same thing. Okay, and we can start to look at that more once we get into homework. You'll kind of see some of that stuff as well. Okay, let's go ahead and flip over to the next page, and let's start to actually try and do these. So for our first one here, let's look at what the problem is asking us. We're given the figure below, and we want to let G equal a translation composed with a reflection of ABCD, where the line M is the line we're reflecting over, and T is the translation given by the vector. So you'll see over here on the side, I actually have a small vector here, x, y. That's my vector that I'm used to do the translation. The line M is going to be my reflection line. So I'm going to start by reflecting over that. Okay. If I look at the order up here at the top, hopefully you're starting to remember we're starting on the right side, so I'm going to do my reflection first. Then I'll come back and do my translation. So let's go ahead and do this. Now I'm going to be doing this with a mirror, okay, which means I'm going to have to spin my paper a little bit. But I'm going to go ahead and put my mirror right on that line. Okay, and you can kind of see that on the screen a little bit as well. The hard part here is I can now see through the mirror. Unfortunately, you cannot. So I'm going to quickly spin my page here and give myself that reflection. Okay, so I'm now looking through my mirror this direction so that I can see my new shape on the other side. As I do that, just want to make sure I'm lined up good here. I'm going to go ahead and plot my points again. So I'm just going to plot where my points actually are. I'm not worried about the connections quite yet, because here are my points. I'm just going to make them look a little bit neater now. Okay, here are my points. If I wanted to connect them now, I could connect them in the same way. So if I quickly draw those in, I'm going to have a straight line going through these three, then kind of my small pieces over to the side to kind of get that flag looking shape. Okay, if I quickly label these, I'm going to call these my primes. So like A prime, B prime, C prime, and D prime. Now, that's only the first half of this problem, because if I look at the top, I had to do the reflection, then I had to do the translation as well. So now I have to do my translation with my vector here. And if we look, part of making this a glide reflection was that that vector had to be parallel to this line. If we look here, it does look like it is. So we're going to go ahead and assume that this is a glide reflection. We don't necessarily have that marked, but that's fine. We can go ahead and make that assumption. Okay? To do this translation with the vector, again, I need to know the distance from my vector here. So I'm going to go ahead and use centimeters. I'm going to go down here and measure from the end of the vector to the very tip, and it looks to be about 2.3 centimeters. So that is the distance I need to move each of these points, and I need to move them in kind of that parallel direction, the same direction that my line here is moving. So let's go ahead and do that. So I'm going to take each of mine. I'm going to start up here with A and kind of work my way down. So I'm going to start with A here. Looks like I'm going pretty much that direction there. Okay, if I go up to 2.3, I'm going to go ahead and put my first dot there. That is going to be my point A. Okay, so I'm going to go ahead and label these as I go so I don't lose track. That's going to be A double prime. Then I'm going to move down to B. Again, trying my best to make sure that I'm parallel here. Go to 2.3. It's going to be about right there. I'll label that B double prime. Then I can do the same thing with C. Move that up 2.3. About right there. Running into a little bit of my prime on the A, but that's fine. Okay, this is going to be C double prime. And then finally, I'm just going to shift over and do D here. Again, doing my best to make sure that I'm parallel. And 2.3 right there. Now that is my point D double prime. Okay, let's go ahead and connect those the same way they were before. So straight line through all three, and my points out to the side. Okay, so my green shape here is my final image. I'm starting with my pre-image of the one that's already on the page. My intermediate shape is kind of that pink one there. Okay, so I'm going to ignore that one. If I look in general, what I actually did, I actually took this shape and I moved it, and we kind of moved it this direction overall, but I also flipped what direction it's looking at. So that's what we call the glide reflection. And if we actually look and actually think of it as doing the flip first, I get the pink one, and then I took that and just shifted it kind of up on that angle to get my green shape. Okay? So that is a glide reflection. And if we look here, we could look at all of our properties. I still have my angle measures are all the same in that top triangle. I have the betweenness, I have the collinearity, and even the distances of these side links are all going to still be the same. Okay? So all those properties are still preserved, but again, I'm flipping, which gives me that reversed orientation. If I go around, I have A, B, C, D in this shape. That would be counterclockwise. If I go here, A, B, C, D, that gives me a clockwise direction. So I have that reversed orientation. Okay. Very last thing we want to do here is kind of summarize all of our transformations. I know we did this in yesterday's notes as well, but now we have a new transformation. So we want to make sure we have everything all together for ourselves, which makes this just a little bit easier to work with. Okay. So let's go ahead and start with a reflection first. So first thing with a reflection is we only need one line. It's the only thing we need to actually do a reflection. We just need one line there. Okay. When I do that, my notation then is just a reflection over that line. And then I'm all set. For a rotation, I need two lines. Okay, but they need to be very specific lines. If it's a rotation, I need them to be intersecting. So we're going to call these two intersecting lines. Intersecting lines. And my notation here is I'm going to reflect both of them over separate lines, and I have that composite or that open circle in between. Okay? For a translation, we actually have a couple options. We can do two parallel lines. Okay, so we can actually do it using the reflections of two parallel lines, or we can do the piece we talked about yesterday, which is using vectors. And I could have a vector as well. And that actually changes our notation as well, because if I'm using two lines, I'm going to do the same notation I use for a rotation. They're just parallel lines instead of intersecting. Or if we're doing a vector, we're probably going to call it just a single letter. Usually we use T for translation, but it could be a different letter as well. Okay? Then finally we get to our glide reflection. Okay? For a glide reflection, I need to reflect over one line, and I need a vector to flip across, or to actually move my shape. So I need one line and a vector. Okay? That means I'm doing a translation composed with my reflection over some line. Okay, so that's my notation there. Okay, this is a nice chart to just kind of be familiar with. This will help you out when you get to your quiz, kind of making sure we know exactly what we're doing for each type of transformation. Okay, at this point you can go ahead and start to work on your homework. Okay, that is listed on the backboard, or it should be given to you as well.